Now, we're going to take up one more problem. The problem number 25. Determine the magnitude of the load P necessary to produce zero net change in the length of the straight bar shown in figure A. Figure A equals 400 mm square. So, uniform cross-sectional bar. This has been asked in August 2001 and also in December 2014 and January 2015. Here, one end of the bar is fixed, having a uniform cross-sectional bar of 400 mm square. So, in the first section, you have P, which is acting toward the left side, and in the second section, 60 is acting toward the right side, and also 40 is acting towards the right side. So, let us assume and also ABCD, AB segment has got 2 meters long, BC segment has got 1 meter, and CD is equal to 1 meter. So now we are going to try to solve this problem. First, we are going to assume let the reaction R at the support act towards the right side. So which is that? So here the section here the reaction will going to be acting towards the right side. So for the equilibrium condition, load acting towards the right side will be equal to load acting towards the left side. So that is, so since we are taking this R to the right side, load acting towards the right side will be R plus 60 plus 40 is equal to P. Load acting towards the left side. So R plus 60 plus 40 is equal to P. Therefore, R plus 100 is equal to P. Therefore, R is equal to P minus 100. So the reaction R will be at P minus 100. Now we are going to take up the diagram of the different segments. So we are going to have the free body diagram. First, we are going to consider the section AB. So if you consider R, which will be equal to P minus 100. So here P minus 100 will be equal to, again we have to consider the, since this is the left side and this is the right side, again you will going to get P minus 100. So which is acting to the left side. So P minus 100 to the left side. So similarly, when you are considering for the second segment, so here P minus of P minus 100. So again P minus of P minus 100. And again on this side, which will going to be 60 plus 60 plus 40. So it is again 100. So here, if you are considering the second segment here, P minus of P gets cancelled, minus into minus becomes plus. So 100 kilonewton. So again P minus of, so here the right section is considered positive. P minus of P minus 60, P minus of P minus 60, minus P minus of P minus 100, it is here. So here in the third segment, what we are considering is R first. R is equal to how much? R is equal to P minus 100. So here R is equal to P minus 100. So the acting towards the left side is considered to be positive. So P right side is minus of P minus 100 minus 60. P minus of P minus 100 minus 60. So what happens? P minus P gets cancels. Minus into minus becomes plus. 100 minus 60, which will be 40 kilonewton. Since it is positive, it is acting towards the left side. Then the load acting here, the right side is positive, so 40. So you are getting 40 here also. So this is how you will be able to analyze this. So there is a compressor in the segment AB having 400 mm square. Of course, it is a uniform cross-sectional area of 400 mm square, having a length of 200 mm. So you can have a compressive load between the segment AB, P minus 100 and P minus 100. When you are considering for the BC, here it is 400 mm square having a length of 1000 mm. Again, you have a tensile load of 100 kilonewton and also 100 kilonewton. Again, when you are considering between C and D, it is 400 mm square, again uniform cross section having a length of 1000 mm. So it is 40 kilonewton tensile. So now we will going to apply for the, since it is a compressive load between the segment AB, so the contraction of the segment AB will be equal to delta L1 is equal to P1 into L1 by A1 into E. So what is P1 of the segment 1? P minus 100. So you're going to consider P minus 100 into length is 2000 divided by area is 400 into E, which we need to find out. So that is equal to 5P minus 500 by E. So then what is the second one? The second one again, you have, it is the tensile load which is acting. It it is not the contraction of the segment, it is the extension of the segment. Delta L2, again it will going to be delta L2, which will be equal to P2 into L2 by A2 into E. So P2 is 100 into L2 is 1000, because this is the length of the segment is 1000 since it is a tensile load. So here extension of the segment BC will be equal to, that is delta L2, P2 into L2 by A2 into E. So 100 into 1000 divided by uniform cross-sectional area, so 400 into E. So that will be, on simplification, 250 by E. Again we have the tensile load is acting in the segment CD. So naturally you will going to have the extension of segment CD will be equal to delta L3, which is P3 into L3 by A3 into E. So what is P3? P3 is nothing but 40 kilonewton, 40 into 10 to the power of 3 into L3 is 100. So if you want, you can keep it in the kilonewton only, 40 into 1000, because L3 is the segment which is having the length of the segment is 1000, divided by 400, which is the uniform cross-sectional area, into E, that is equal to, on simplification, 100 by E. So therefore total change in the length of the bar, which will be delta L, will be equal to delta L1 plus delta L2 plus delta L3. So what is the total change in the length of the bar? 0, because here in the problem he says 0 net change in length. So since it is 0 net change in the length, so obviously delta L will be equal to 0 minus delta, that is equal to delta L1 is in the contraction. So what is the contraction? Minus of 5P minus 500 by E. So that is the reason why minus of, so contraction in the segment AB, minus of into minus of 5P minus 500 by E. So that is the reason why we are written minus of 5P minus 500 by E, because due to the contraction, plus what is delta L2? It is 250 by E plus 250 by E plus 100 by E. So that is 0. So E goes, everything is 0, on minus 5P plus 500 plus 250 plus 100. So it will be minus 5P plus 500. So again, so that will be, so you can take out the entire thing as the common fact, take it to the right hand side. 5P minus 500 is equal to 350. So you take this to the right, you can take this 350 to the right side, 500 to the right side, negative becomes positive, 5P is equal to 850. Therefore, on simplification, load P will be equal to 170 kilonewton. So this is how you will be able to find the load P, which is necessary to produce 0 net change in length. So the value of load P will be equal to 170 kilonewton. So this is how you will be able to find the solution. Now we go for the next problem, wherein problem number 26. Determine the stresses in the various segments of the circular bar shown in the figure. Compute the total elongation, taking the Young's modulus to be 195 GPa, which is again the examination problem which is asked in September 2000. So this is the problem number 26. In the first segment, you have a diameter of 20 acting toward the left side of 100 kilonewton. In the second segment, having a diameter of 25 to a length of 200. On the left hand side of the diameter 25 segment, you have 300 kilonewton acting towards the right side. And again, in the other end, it will go to act towards the left side by 250 kilonewton. And then in the third segment of diameter 15, having a length of 150 mm, P4 is acting towards the right side. So now we need to write the solution. First, we need to find out the value of P4 according to the equilibrium condition. So what is the requirement? For the equilibrium of the bar, load acting towards the left or the right side will be equal to loads acting towards the left side. So what is that? Loads acting towards the right side, 300 is acting towards the right side. 300 plus P4 is equal to 100 plus 250. So 300 plus P4 is equal to 100 plus 250. Therefore, load P4 will be equal to 50 kilonewton on simplification. So now we are going to apply the free body diagram of the different segments. So first we are going to take the diameter 20 of the length of 100 mm. So first on the left hand side, you are going to have 100 kilonewton. So what is the sign convention? The sign convention acting toward the right side is positive and acting toward the left side to the right one is negative. So according to this, this is acting toward the right side, so plus 300. This is acting toward the left side to minus 250, and this is acting toward the right side plus 50. is the one which we want. So 300 minus 250 plus 50. So on simplification, you will going to get 100 kilonewton. Since it is positive, according to the sign convention, it is acting towards the right side. Therefore, in the other end, 100 kilonewton is acting towards the right side. Now we will go for the second segment, which is BC. So again, according to the sign convention, so here 100 kilonewton is acting towards the left side, which is positive. 100 minus 300. So that is 100 minus 100 plus 300, which is equal to 200, which is acting towards the right side. So since it is acting towards the right side, we are considering as positive. Acting towards the right side is positive. Acting towards the left side is negative. So according to this convention, minus 100 plus 300, which is again 200, which is acting towards the right side, which will be equal to, again, if you are considering here, minus 250 plus P4 is 50, minus 250 plus 50, which is equal to minus 200. Since it is acting towards the left side, according to the sign convention, you can see here, this force acting towards the left side is negative. So therefore, you will go to get minus 200. So since it is minus, it is acting towards the left side. So it is acting towards the left side on this end. Therefore, the overall free body diagram of BC will going to have the compressive force. Similarly, when you are considering the segment CD, so according to the sign convention, load acting towards the right side is positive and load acting towards the left side is negative. So according to this, so minus 100 plus 300 minus 250 plus 50. So that is what we want. So here on this side, minus 100 plus 300 minus 250. So it will going to be minus 350 plus 300 is equal to minus 50. According to the sign convention, minus is acting towards the left side. Therefore, you can see it is acting towards the left side by 50 kilonewton. And since it is in the sign convention, the load acting towards the right side is positive. So according to this, since P4 it is acting towards the right side, so what is the value of P4 is equal to 50. So in this case, here also you can see it will going to be 50 is acting towards the right side. So this is how you will be able to summarize this. So what is the summarization? The segment AB has got a tensile force or the tensile load, and the segment BC has the compressive load, and the segment CD again you have the tensile load. Now we are going to take the stresses in the segment. So stresses in the segment AB, which is the sigma 1, which will be equal to P1 by A1. So what is the value of P1 here in the segment 1, which is 100 kilonewton. So area, so that is sigma 1 is equal to P1 by A1. P1 is 100 into 10 to the power of 3 by A1, pi by 4 into 20 square. So pi by 4 into 20 square. So it will be equal to 318.31 Newton per mm square. Since it is a tensile load, you are going to get this tensile stress, which is therefore sigma 1 is equal to 318.31 Newton per mm square. Now when you consider the stress in the segment BC, again you have the load by the area of cross section. So here it is 200 into 10 to the power of 3. Sigma 2 is equal to P2 by A2. 200 into 10 to the power of 3 divided by pi by 4 into. So what is the area of the segment, which is 25? So the diameter is 25. So pi d square by 4, which will be equal to pi by 4 into 25 square. So on simplification, sigma 2 will be equal to 407.437 Newton per mm square. Since it is a compressive load, the stress developed is compressive stress. Now we will go for the stress in the segment CD. So what is the stress in the segment CD, which is sigma 3, which is equal to P3 by A3. Again in the segment P3, that is the segment CD, you have a tensile load of 50 kilonewton. So 50 into 10 to the power of 3 by pi by 4 into 15 square. On simplification, sigma 3 will be equal to 282.942 Newton per mm square, which is again tensile. So now we will go for the elongation of the segment EB. So what is the, since it is a tensile load which is acting on the segment, so naturally it will going to be the extension. So delta L1 will be equal to P1 into elongation of the segment AB, which is delta L1, which is equal to P1 into L1 by A1 into E. So P1 by A1, what we know is sigma 1 into L1 by E. So what is the value of sigma 1? It is 318.31. You substitute that value in sigma 1 into length of the segment is 100 into 100 by E, 195 GPa, 195 into 10 to the power of 3, which is equal to 0.163 mm. Now similarly, contraction of the segment B2, contraction of the segment BC, which will be delta L2. So what is that? 200 into 10 to the power of 3 divided by pi by 4 into 25 square. So that is what we want to do here. Delta L2 will be equal to P2 into L2 by A2 into E. P2 by A2 is nothing but sigma 2 into L2 by E. What is the value of sigma 2? Which is 407.437 into L2. L2 is 200 mm. That is the length of the segment, 200 mm. And then divided by E, because P2 by A2 is our sigma 2 by E. E is 195 into 10 to the power of 3. On simplification, you will go to get it as 0.418 mm. Similarly, when you are considering the segment 3, again you have a tensile load. Again you have delta L3 will be equal to P3 into L3 by A3 into E. P3 by A3 is nothing but sigma 3 into L3 by E. So here L3 is 150. So now we will go for that elongation of the segment CD, delta L3, sigma 3 into L3 by E. So what is the value of sigma 3? Substitute that value, 282.942. 282.942 into 150 is the length of the segment. Here length of the segment is 150 divided by E is 195 into 10 to the power of 3. On simplification, you have got 0.218 mm. Now what will going to be the total change in the length of the bar? The total change in the length of the bar is given by delta L will be equal to delta L1 plus delta L2 plus delta L3. So the delta L1 substitution value is 0.163, which is the elongation, so positive. So delta L2 will be contraction, it is minus 0.418 plus elongation of the segment delta plus delta L3, 0.218. So 0.163 minus 0.418 plus 0.218. On simplification, therefore delta L will be equal to minus 0.037 mm. Therefore total change in the length of the bar, delta L will be equal to 0.037 mm contraction. So since it is a contraction, naturally it is going to be the decrease in length. So this is how you will be able to solve this particular problem. Thank you.